Welcome to this talk on kubectl. Apply your cloud infrastructure using tools like Crossplane and also other tools. So I promised you to show you a picture where I'm broadcasting from. So this is me here in a small town called Rosenheim. This is the town where I live. This is a town where we have an office. Our headquarters in Munich. I work for a company called Coaware. We are a custom software provider, right? We do custom software development mainly in the cloud native universe, and obviously also in the platform engineering universe. So we've built several custom platforms for large enterprises like the big German automotive company, which is located in Munich, for example. So let me tell you a little story how I came to platform engineering. It was about 4.5 years ago, and we had a huge project tender for one of our customers. And that was challenging in many, many different aspects. First up, it was like monolithic applications, mainly run on-premise, fully managed, old school type infrastructure. The customer had the plan to migrate all of these applications towards the public cloud. It was a DevOps project, so we had 24/7, we had hard SLAs. So this was kind of new to us. And that is where we started 4.5 years ago with several challenges, but we accepted the challenge. And obviously, you guessed it, we started quite naive. I'm a software engineer, I'm a software architect in background. And what do we do if we talk about, building systems? You have to work in layers, right? As software architects, you always think in components and layers. This is good old Bob Ross here. He always talked about painting images in layers also. So what did we do? So we came up with 5 layers in cloud native software engineering. So at the bottom, we thought, okay, if we want to build this infrastructure, obviously we have to use some infrastructure as a service components in AWS. In our case, that was. So we talked about network, we talked about compute. We thought about how to set up all the, the networking and the VPCs, and how do we model all the environments. And so that was the base layer. On top of that, in our case, it was an EKS cluster. Obviously, we wanted to use some managed Kubernetes service of the cloud provider. Above that, then, we already knew we need some form of platform. We need to think about CI/CD tool chaining, some general platform components like, monitoring, compliance, security, maybe some application catalogs, some application blueprints, and also a developer portal, maybe. Above that, we knew the microservice and the applications we build would need some application-specific software infrastructure, like maybe a relational database, or maybe an SNS topic, or an ECR to store your Docker images. So these are infrastructure components, software infrastructure components that the actual applications would need to run, okay? And above that, we had like Java and Quarkus in our case. So we were highly in the Java universe in that case. And naive as we were 4.5 years ago, we thought, oh yeah, that can't be too hard, right? But we quickly realized that we totally got into this mental overload, right? Productivity dropped, and the product owners were not too happy about that. So we knew we had to change something. I guess you all know this book here, right? This pretty much describes what we were actually suffering. We had too much mental load, too much cognitive load, and that definitely became a bottleneck for our productivity. So we knew we had to change something. Fortunately, obviously, this book also made some suggestions, and basically what it proposed is, well, introduce a platform team. That one is, responsible to build and operate a platform, so to support the other teams in their day-to-day development work. So we had kind of those streamlined teams. Those were the application developers, and then we now had a platform team who is now responsible for kind of building that platform. And this is pretty much, let's say, 3.5 years ago, how we ended up structuring our teams. Right, so we structured our teams, and now we had like 2 types of engineers. We had the cloud native application engineers and the cloud native platform engineers, and the interface was now the platform. So obviously down here, at the very bottom layer, we use Terraform, we use TerraGrunt. This is, I think, a sound decision. But what we didn't want to do is, we didn't want to expose our application engineers towards Terraform and TerraGrunt, right? The application engineers, they're used to write their YAML. They can write the Docker file, they can write a Helm chart, or maybe some, some customized stuff. So how could we, especially for the application-specific software infrastructure, provide them with similar means to create and manage and deploy those application-specific software infrastructure? Now, the idea is pretty straightforward, right? Why not model your cloud infrastructure as Kubernetes resources? I mean, you have your microservice and you use deployment and service and config map and all that. Why not model your ECR repository or your S3 bucket or your relational database as a Kubernetes resource as well? So in a Kubernetes world, this is pretty straightforward. You could define a custom resource definition that kind of allow you to have user-defined declarative extensions of the Kubernetes API. So all you have to do is write a so-called custom resource definition. This is a huge YAML file. You can, model and build abstractions of even complex application constructs. And once you apply this custom resource definition to your cluster, you will have like default support for all different types of API features. You can create, read, update, delete those resources. You can watch them. You can discover them. You can apply admission webhooks, all the fancy Kubernetes stuff. And this is what it could look like. I mean, this is a sample, right? So on the left-hand side, you see the custom resource definition to kind of model an ECR repository, for example. So what you do on the left-hand side, you describe the names and the plural and of this custom resource. And then in this Open API v3 schema definition, you define what the resource actually looks like, which fields does it support, and which structure does it have. And on the right-hand side, you now see how this could look as, the good old trusty Kubernetes YAML, how such a repository could look like. So you could specify a tag immutability, for example. You want to specify the image scanning configuration, and obviously your repository should support some form of encryption. Now, only having that, your cluster cannot do many things with it, right? This is just declaring things. So to make that work, what you would need to do in a pure Kubernetes world is you have to build an operator. I'm sure you heard about that concept. So this is here the high-level view of an operator. So an operator is a piece of software that lives inside your platform or inside your cluster. It tracks those custom resources the user modifies or creates. And then the operator, on any change event like added, modified, or deleted, the operator will make sure that it adjusts the current state within the cluster, and in our case, also within the cloud provider. Because if we create, let's say, an ECR repository within our cluster using this custom resource, obviously what we also need to do is we need to create that cloud resource also. So we kind of have like two states which we need to maintain. So this is sometimes a little tricky, okay, but not impossible. So if you want to build such an operator, then there are quite a few ways to do that. I think the most straightforward one is to use the operator SDK. So if you are able to program in Go or in Java, for example, then it's kind of straightforward to implement such an operator. So if you're interested, I'm not going to show you this one, right? But if you're interested in the code, example code, please do not use in production, then have a look at this Git repository here. It took me like, I don't know, 2 evenings on the couch to implement that. So for the repository, okay? And repository is a really simple resource. Now you might say, oh God, facepalm, are you really serious, Leander? I mean, isn't there something simpler? Isn't there something easier? And the good answer is yes, of course there is, okay? So please don't start building this operator yourself. There are quite a few tools out there that can achieve the same, okay? And that have a bigger community, and you don't have the burden to maintain that operator, okay? And this is what this talk today is about. Maria said you get the slides afterwards. You can also have the code. I'm going to demo and showcase to you in a few minutes, okay? So these are 2 repositories, and the demo is mainly in the first repository here. So go on our GitHub webpage. It's K8S native infrastructure as code, IAC, where you find all the demo files for today. And this is kind of the demo I have prepared for you. I have an EKS cluster running in AWS. I have a GKE cluster running in Google. On the Google cluster, there's a component called ConfigConnector, which I'll show you in a second. there is Crossplane installed. And on the left-hand side, I have something called the Amazon controllers for Kubernetes, ACK. That's also a component that is very similar. So these three components pretty much do exactly the same thing, slightly different, obviously. They can be used to manage cloud resources declaratively, cloud resources in a Kubernetes way, okay? And this is what we wanted. So let's briefly look at the ConfigConnector. So ConfigConnector is a Google-specific operator, a Google-specific project, okay? And it comes with the Google Kubernetes engine. So what you can do with it? Well, obviously, you can define and use Google Cloud resources directly from Kubernetes. So if you want to have a storage bucket within your Google project, then you can use the ConfigConnector to create that one, but manage the resource via Kubernetes. Okay, so you don't need to define your resources outside the cluster anymore using Terraform or any other infrastructure as code tool. You can add the ConfigConnector during the initial installation of or creation of your cluster, but you can also enable it obviously later. You need to do some in-cluster configuration afterwards, after the initial installation. I step you through this one. You need a dedicated service account with the suitable permissions so that this service account is then used to create those resources. And right now, I can say currently all major Google services and resources are supported. So back to our storage bucket or maybe a SQL database. Again here, a bit of YAML on the left-hand side. You see, for example, storage bucket. This is a resource you would create to create a storage bucket. You can specify lifecycle rules like please delete all files after 7 days, please version this bucket, and give it the following name. Now, also time for the first little demo. Okay, so this is the repository I was talking about. If you have an AWS account and a Google account, then you can use this makefile I provided to quickly spin up those two clusters, and then you're almost ready to go. Now, what you see here, to configure and enable the ConfigConnector, you need to add a few YAML files to the cluster. Down here, you have this ConfigConnector definition. And you see here, there's a service account referenced. That is the service account used when you create the resources. You can specify a mode. Does it operate on the cluster level or does it operate on a namespace level, which is maybe suitable to if you have kind of a multi-tenant namespace isolated platform or cluster that many teams use, then you should probably use the namespace version. But for now, it's cluster. And to tell the ConfigConnector that all the resources created within a specific namespace, what you can do is you can label or add an annotation, in that case, add an annotation to your namespace and just tell the ConfigConnector which Google project the created resources should end up in. Okay, so once we have done that, well, I hope this is big enough for all of you. So let's go big. So we go here. Let's see. So I have a few demos. We have the ConfigConnector here. Let's see if we, the storage bucket, right? This is the YAML I showed you before. Okay, so basically here, or I can show you here. So this is the bucket. Okay, so this is what the YAML looks like. Just to show you that I'm not tricking you, let's see. I display all the buckets that are currently there. You see, there are no items there. So what we now do is we say, okay, apply -f using the storage bucket YAML. Okay. So we apply that one. So that's looking pretty good. Kget. Oops. Let's see. Wait. -n. Wrong namespace. ConfigConnector. And there you see, it's already ready. The status is up to date. So if I run the gcloud command from just before, you see that within my Google project, I now have the storage bucket created. Now, obviously, this YAML, hopefully no developer applies that manually, but all you need to do now is commit this YAML maybe to your Flux repository where all the definitions are, and use some proper GitOps workflow to automatically apply and reapply all those resources. And this is how most of our developers work nowadays, right? No one touches the cluster, everything is GitOps managed, and you now have the possibility via ConfigConnector if you are in the Google Cloud. Now you might ask, I don't have a GKE cluster. What happens if I am in AWS? Well, lucky you. There's also a similar controller, which is called the Amazon controllers for Kubernetes. Again, here, this one also allows you to define and use AWS service resources directly in Kubernetes, like with a ConfigConnector. Same thing here, you don't need any Terraform. Slightly different here, for each and every AWS service, you have a dedicated controller. So you need to decide which of these cloud resources do I want to provide my application developers, right? With a ConfigConnector, you get everything that is potentially supported. Here, as a platform engineer, you can pick and choose the dedicated and desired controllers you require. So S3 controller, ECR controller maybe, and maybe the RDS controller, and nothing else, which is kind of neat, you know, from maybe a security and compliance perspective, for example. What you need here is you need to have dedicated IAM roles for your for service accounts to automate the provisioning. So you can specify also here the correct credentials for all those controllers. Right now, there are about 20 different controllers released, so not each and every AWS resource is currently supported by this project. A few of them are still in preview and or maintenance phase. So you need to pick and choose the right ones, which you are, you know, let's say, which you need, obviously, and which you dare to run in production. So maybe only choose the released one and the stable ones. So just to give you an idea with the bucket and repository, so you see here, this looks pretty familiar. This looks pretty much the same as the custom implementation, and it also looks pretty familiar compared to the ConfigConnector. All right, so again, you write a bit of YAML, the application engineer, to create a bucket, or maybe to create an ECR repository to push the Docker image of his microservice in. Again, using this approach, you can provide the developers with the declarative means to manage those cloud resources. So let's go on further. Installation is a bit tricky of this one. So I kind of put all the steps in here, but now I need to switch the cluster. So I need to switch to my EKS cluster now, right? Because obviously this controller only works in the AWS world. So let's see how many S3s do I currently have. So this is kind of what we have here. So let's see, we need to change the directory down here. Up, up. S3 bucket. Okay, so it says, okay, bucket was created. Up, let's see. So this one is right now 6 seconds old, so everything should be neat. Let's see if we do that. ACK demo bucket, and up here using the AWS CLI, you see that within my AWS tenant, within my AWS VPC, I now have that bucket created. And this is again very, very similar to all the rest. So this is for A3, for example. So this is what the bucket looks like. You can have like an ECR repository, for example, and you could also have a whole Aurora database, for example, right? But you see, it gets rather long-winded here. So you have to create a few more resources to get that working. Okay, then quick look on the clock. So we're already quite advanced in time, but we will manage. So that is AWS covered, and that is Google covered. What I'm not going to show you is kind of the pure Azure alternative. So obviously there's a similar project out there. It's called the Azure Service Operator, and it's pretty comparable to the other two. It's an Azure-specific, AKS-specific controller version to manage Microsoft Azure resources declaratively. Now, let's come to the big boy. Let's come to a project called Crossplane. Crossplane is kind of, they call themselves the universal control plane for cloud infrastructure. And basically what Crossplane gives you is super generic, and they provide a ton of different cloud providers, okay? They support AWS, they support GCP, they support Azure, they support Alibaba, and many, 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 many others, okay? So it's kind of the Swiss Army knife. It's very flexible. Each and every one of these providers, well, the name says it, is provided by something called a provider within Crossplane. And it also has something called composite resource definitions. And these are very, very useful from a platform engineering perspective because it provides the platform teams with the means to provide abstractions, to provide simpler to use resources and provide these towards the application teams, right? And I will show you how that works in a minute. So again, what does the developer have to do? Well, write some YAML. So on the left-hand side, you see now the Crossplane variant of creating an S3 bucket using Crossplane. Very, very similar, right? So it's a standard resource. You can give it a name. You can give annotations. You can give labels. You see here, using annotations, you can kind of control certain behavior of Crossplane, for example. In the spec section, you, for example, have a deletion policy. So this is kind of important. Deletion policy is delete. There's also the value of abandon or orphan, which means what happens if you delete the resource within Kubernetes? Should the resource within your cloud account also be deleted or not? So for an S3 bucket, maybe not so relevant, just delete the bucket once I delete the resource within my cluster. Maybe for a database where you have valuable data in, maybe you should think twice if you want that one deleted if you accidentally delete the resource from the cluster, right? Maybe you want to back up the data before you then delete the stuff. And you can configure the resource, again, using loads and loads and loads of parameters. Now, resource definitions, or these composite resource definitions, they allow the platform engineering team to define developer-friendly abstractions. And I will show you in a second why that is required. Because using Crossplane can get quite nitty-gritty and quite detailed. So to properly configure, for example, an S3 bucket with a lifecycle policy, with versioning control, with an access control list, and with many, many others. So this can get quite complex suddenly because you have to create many, many fine-grained resources. And you don't really want the developer to do that, right? There are many mistakes you can do. So we want to reduce the cognitive load on the developer side. So what the platform team can do, it can provide a composite resource. Now, I show you that on the example of, let's say, an ECR repository. Let's do that one. So we go here in my Crossplane folder, right? Here are some examples. So let's see here. So this is what a bucket looks like. Not too complicated right now, okay? So if the developer wants to create an S3 bucket, he would have to write that one here. But as I said, if you want to additionally enable ACL, you also have to create that resource here. And if you want to create a lifecycle configuration, then you have to write that YAML here. And if you want server-side encryption configuration, then you have to write that YAML here, right? So if you want to enforce some standards, I mean, it's pretty hard using this approach because the developer is free to do whatever he likes. So what if I tell you, I can simplify that, I can abstract all these, and I can make Crossplane create those resources under the hood for me and provide the developer with, let's say, a virtual resource definition. And this is what a composite resource definition is actually about. So let's close all these. What I want the developer to do is, this is all he needs to do. All he needs to do is provide the bucket name and provide the region. All the other settings, the lifecycle policy, the server-side encryption should not be modified anyway. This should be on per default. The ACL, everything should be set with sane default values, with compliant and secure default values, so the developers cannot make any mistakes anymore. And also, it makes his life easier, because now all he has to do is write 12 lines of YAMLs, and under the hood, all these other resources are created automatically. So how does that work? Now, well, first up, I need to define, or the platform team needs to define an API extension to Crossplane and provide a Crossplane-specific composite resource definition. And this works pretty similar to the composite resource definition that comes with plain Kubernetes. So again, here, for this virtual resource, I want to specify the schema that defines all the all the parameters and their types, and which ones are required and which ones are optional. So we have that. So the platform team needs to create that file, and then it now needs to create the so-called composition. And the so-called composition now, well, the name says it, it composes all the different individual, single and small resources that need to be created. So in this composition here, I create the bucket, okay? I provide some default values. And here in this patch section, what I can now specify is which fields of the virtual resource need to be kind of copied over to that actual resource that is now created by Crossplane and also managed by Crossplane. Here is the encryption. Again, I provide a few patches. And you see here, again, I copy over a few fields. You can do some transformations, right? You can use formats, and you can do to uppercase to lowercase. You can add hashes and all that. So we kind of have a few functions available to modify the values once they're copied. Same here with the lifecycle policy. I apply that, I patch that, and everything's good. And now, having applied that to the cluster, what I can then now do is, right? So we go to the, let's see where we are here, AWS examples, and we do here, we do like the S3 bucket, for example, right? So that is this one, which I don't want to apply. And now we go to the XRD and we do the S3. Okay, apply -f examples. Okay, that's the example repository. We do that. So I already created that one. And I wanted to create a bucket. So where's that one? S3. What is it called? Oh, I called it bucket. Bucket. Like, okay, apply. F examples, example bucket, right? So it takes a while now. So you see, I've already tried my demo beforehand. So we do that. Bam. So it's already synced. It's true. So AWS S3LS. So some here. This is the bucket we just created. So that is the example XRD bucket. So if you need more flexibility, then definitely Crossplane is the way to go. If you are in a pure, cloud provider, let's say vendor locked in world where it's Azure and it only needs to be Azure, then maybe it's worth to have a look at the cloud provider specific alternatives. I mean, this is, pick and choose. Both, all these things I showed you basically provide the same mechanisms. Crossplane is the most flexible one. It's the most complete one, I would say. In the Google world, the ConfigConnector is also totally complete, and for the others, you have to see if they support your needs. All right. So in the repository here, you find how to install Crossplane using Flux, for example. So this is a fully GitOps-enabled repository that is pretty self-explaining, I hope. So I invite you now after the Q&A session, check out that repository if you want to play around afterwards. and have some fun, give me some feedback if something doesn't work. Pull requests are highly welcome. All right, that's it on time, I would say, right?
Yes. Oh my God, 3 minutes. I don't know how you did it. Very cool. Thank you so much for this amazing presentation, Mario. And what about code? Are you going to pass it over to me, or how do you want me to share it with everyone?
Well, no, I don't need to share the code. I mean, I guess
Repo. Okay, okay.
as a developer, you should be able to. It's just a Git repository. It's hosted on
Yeah, yeah.
GitHub. So just go
Got
on
it.
GitHub, clone the repository, and you have the code. This is
Yeah,
the easiest.
perfect. Yeah, and we'll send over the slides to everyone, so you will have that, and it says in the slides. Perfect. So let's jump into questions. I don't know if you remember the part when Pramod asked, how will you handle secrets in Kubernetes? If
Oh,
not, we can,
that's
ask.
one. Maybe no, let me. So obviously, if I'm assuming you mean like the secrets, for example, if you create a relational database and you need some way of getting the actual secrets to access that database. I hope that is the question. And the best thing I can do is to show it. In case of Crossplane, for example, you see down here. So what you can, or Crossplane is able to do, is once it creates the database, it can then write back the required credentials that are required to access the database and dynamically populate a secret for you. Or what you can do, in this case, for example, if you want to specify the admin password via a secret, you could also tell Crossplane or this Aurora database, hey, please reference the following secret found in the following namespace with the following name. Please use the following key and use the value of that secret to populate the master password. So Crossplane is very able to kind of do kind of a bidirectional synchronization. It can use existing secrets, or it can also populate new and dynamic secrets and keep that one. So then in your microservice, you can then mount that secret here. For example, this here, you can mount that secret into a microservice, so you can then establish the database connection.
Nice. Next question. What are your thoughts on creating complex compositions using Golang templation function? Is there a good alternative?
Ooh, oh, that's a hard one. I'm not sure if there's a good alternative. I mean, there are many alternatives. And I would say you probably have to use that, or the one alternative that is the most suitable for your platform team, I would say, right? I mean, there's so many opinions. Is it Go templating, or do you customize, or do you write plain YAML and don't use templating at all, right? So I guess pick your own poison and choose what your team prefers the most, so they are productive, right? I mean, this is what we want to achieve.
Yeah, I see some attendees are raising hands. Unfortunately, this is listen only. Everyone is in listen only mode. Only Mario and I can actually voice out the questions. So I would ask you to put the questions in the Q&A section.
Yeah. And if you want to get in contact afterwards, I'm also a member of the Slack channel, of the platform engineering Slack channel. So you can definitely find me there.
Exactly.
Twitter, LinkedIn, all there. Get in contact if you have questions afterwards.
Exactly. Or I was trying to convince Maria to come to our House of Cube party during KubeCon. So you guys can check out as well. We'll be hosting our platform engineering event during KubeCon in Paris. So if you are there, check it out.
Yeah. I don't know if I'm there yet. I just said before, I need to convince my wife that I can go to Paris without her. So that's kind of a family issue to solve first. And then I maybe see you in Paris.
Exactly. Cool. No other questions. I guess you made it very clear to everyone.
Anyone going to FOSDEM? So no, not this time.
Oh, we see the question. Okay.
I see the chat. I'm following the chat.
Yeah, exactly. From my understanding, each provider is installed as its own pod. Can this overload the cluster?
Well, oh, that's a good one. I mean, there has been some major refactoring for Crossplane, for example. I mean, the first versions of Crossplane, they installed like, I don't know, 600 CRDs into your cluster, and it definitely kind of was stressing your cluster quite a lot. After the redesign, what you now do is you can pick and choose each individual cloud resource that you want to support. So I would say with this new design, the burden towards your cluster should be, well, as minimal as possible or as bearable as possible. But obviously, it's an additional component on your cluster, and your cluster should be big enough to, right? I mean, you don't only install that component and that Helm chart. You have a monitoring stack, and you have lots of other, platform components installed, and you need to accommodate the workloads. So you should have set up your cluster autoscaler properly. So in case of any, load spikes and peaks, your platform will still work properly.
Have you ever used Crossplane functions, or do you plan to use them?
And the quick answer is so far not. So far not, right? We didn't have the requirement for these yet. So it's in our case, I mean, for us, the developer is S3 bucket, RDS, ECR. So this is right now what we're currently supporting, because most of the microservices the application teams need. So we're pretty basic at the moment.
You can have one Crossplane for managing multiple environments, something like a control plane.
So where's that question? Where did you?
It's in the chat.
It's in the chat. Where's the chat?
Sorry, Q&A.
So Q&A first. Where's the Q&A? There. I'm only seeing Crossplane functions right now. Planning to use it?
No, jump to the open ones. You see on the left, you can have one Crossplane for managing multiple environments. Can you have one Crossplane for managing multiple environments?
Let me quickly think. Now, I mean, what you need to do for Crossplane as well, I mean, you need to specify, you need to give it the proper credentials, and these credentials are then, so what you always need is kind of a service account is also, and the credential to manage the resource within the component. So I don't know if I would actually do that. I mean, Crossplane is really slim on the cluster, right? It has just a few ports. The control plane is really tiny. So I would not go this, add this extra complexity. I mean, if you have 3 platforms, I would simply do like, 3 individually install 3 Crossplane instances on each platform instance. That would be my, always use the simple approach first, because you make it too complex, would be my approach.
Yeah, there is more clarification to that question. It's more about security and control for the clusters. We are using a GCP ConfigConnector per namespace per environment.
I guess all these provide you with enough. I mean, this is the usual, I could now say it's it depends answer, right? I mean, each and every use case in each and every platform is probably has different requirements. So I would say and different security requirements, different compliance requirements. So if you're in the highly regulated world, then obviously you need to, slim down the installation and restrict it even more. So I would say you need to configure it to match your needs, right? And right now in the demo, I use the ConfigConnector and the global namespace. If this is the platform for, I don't know, 1 to 5 teams that are closely related, I guess the cluster installation of the ConfigConnector is just fine. If you have more of a multi-tenant thing where you don't trust each other, then you have to choose the other approach. And I mean, with Crossplane, what you can do is, I didn't show that part. There is something called a provider config, okay? And so if you install the AWS provider, for example, what you can do is you can specify multiple provider configs. In each of these provider configs, you can technically use a different service account. And these different service accounts can obviously be configured differently using different cloud permissions. And then within the resources you create, what you can do as a team or as a platform engineer is you can either choose that connector config or that connector config. So yes, you can do that, but if you should do it, this totally depends on your platform setup, right? And your security requirements.
Nice. I understand that there is a one-to-one mapping from control plane to manage Kubernetes cluster. There may also be some limit to how many resources a single control plane can manage. Any advice on how to organize multiple clusters?
Well, to be honest, that is a tough one, and I would say no advice I could give you right now. I would really need to think about that a bit longer.
Well, maybe Robert, you can reach out to Mario over platform engineering Slack. So.
Oh yeah. I'm happy to go into a deeper discussion, but I would need to think about that a bit more.
We get all sorts of questions here. Next question. Can this reliably replace Terraform in its state as of today?
Well, I would say yes, right? Maybe someone disagrees. In my opinion, it's, I mean, each of these approaches has its place, right? But at least if you ask my colleagues that are more on the application engineering side, they are, let's say, scared of Terraform, or they don't want to use it. They want to stay in their productive ecosystem. And this is writing some YAML, this is writing some Java code. So I guess for them, using this declarative approach is the answer. And I mean, the state of the S3 bucket, once it's created, I mean, it stays inside the cluster. The state is inside your etcd, stored there. So I would say etcd is a proven component of any Kubernetes cluster. So it is definitely safe to store the state there, I would say. Cannot be lost that easily, right? I mean, state handling in Terraform isn't easy either. I mean, do you store it on an S3 bucket? Do you put it in your GitLab repository? What do you choose? Hopefully you don't store it locally on your machine. So this can be tricky as well.
Cool. And the last question, just wanted to know about Crossplane outputs data like Terraform, for example, EC2 public IP.
I would say yes. Well, not everything properly, but the most relevant information is either stored in the status of the resource, and you can kind of query these fields as well. But I'm not sure if in this case for the EC2 public IP is that the case. I'm not sure about this, but it does output some data similar to Terraform.
Nice. And the last question, you mentioned using good GitOps pipeline in combination with Crossplane, and Go can give you, can you give an example on what makes it good?
Now, for the one who asked that question, what do you mean? Is it the combination? Is that, you mean why that is good? I mean, GitOps in general, I think, is a good idea. No one, in my opinion, should nowadays touch the cluster manually using some kubectl commands. maybe in the dev environment, but not at any later stages. I mean, this has something to do with reliability, with operability, right? I mean, once you are in production and you have a dedicated team or a dedicated SRE team, everything needs to be, you need the Git history. You want to have the accountability. You want to be able to revert any malicious changes, maybe, or anything. So storing the state of your deployment in a Git repository, what GitOps is all about, is definitely a good idea, right? And in our case, for many customers, we do not even get direct API access to the Kubernetes cluster, right? So GitOps is the only way to do that anyway, to deploy something on the cluster. So, if you're regulated environment, insurance, banking, for example, right? The clusters are super isolated. And I mean, obviously, if you start managing your microservices and these deployments using GitOps, then yes, I think everything that composes your application, the repository and the database definition, and the bucket definition, for example. I mean, this is the application. It's not only the microservice. So each and every part of the application should be version controlled. So yes, and that is why I think this makes it good. This is super simple, right? Your SAEs, your developers, your ops team, if you have one, the interface of communicating and the interface of working together is that one repository. It makes it simple. So that's why I think that this is the reason why it makes it good.
Yeah, simple and fast is always good.
Simple and fast, right? We love that.
Yes. Well, with that, I don't see any other questions. I screenshotted one for you, Mario, if you want to think about it. I also posted in the platform engineering Slack channel, and you can provide an answer over there.
Yep.
We'll send over slides and webinar replay to everyone who registered, so you should see it in your inbox tomorrow. If not, feel free to ping me, and I'll make sure it is sent. Do you want to take one last question? I see there is one more popped up. Is there a workaround for a dry run still on their roadmap?
So where's the question? There.
It's in the chat, in Q&A. God, I confuse them all the time.
And Philip, I don't know. This is the honest answer. I don't know. I don't know any workaround. Sorry about that.
Yeah, we only do simple and fast. That's the answer. Cool. And yeah, we run the sessions every week. So if you're interested in more sessions, check out the platformengineering.org so you can see what's out there. And don't forget to join Slack, since if you want to be an active part of the community, definitely that's a place to be. But thank you so much, Mario, for driving the session today, and hope it was insightful. Looks like many people said that it was. So thank you so much for it, and hope everyone has a safe and amazing rest of the week.
Yeah. Thanks also. Thanks to the audience. Thanks for having me, and have a good day. Have a good evening.
Yeah, great questions today. Thank you, guys. Bye.
And